Colin, you're not videotaping somebody, I hope, that doesn't want to be videotaped.
What the heck?
That is illegal, actually.
Oh yeah,
I don't know. I can't keep track of your
God.
Colin, I need to place you on a citizen's arrest.
No.
You have the
You need
right
to arrest me. God. See what I deal with? See, vlog, this is what goes on in my school. God. Unbelievable, vlog squad. Can you follow? I have my Chromebook.
I didn't do it.
I did it.
The whole time I'm trying to explain this.
Yeah. Okay, come on, guys.
Are we ready?
Get it together.
If I keep having to stop and go, the learning doesn't happen as well. Okay? As it should if I can just finish. So, alright, so first part we were asked to figure out was the change in momentum, which is this right here. So with that negative sign, we're going to take that, we're going to say 0.34 times a negative 38 minus 0.34 times 22. So because momentum is a vector and it's dependent on the velocity vector, we need to make sure that we include that negative when it is appropriate, okay? So if we multiply those together and then subtract, we should get a change in momentum equal to negative 20.4 kilograms time meter per second. Why does it make sense that it's negative?
Because it's going in the opposite direction.
That would normally be the answer, but just based on the calculation here, why does it make sense that the answer turns out to be negative?
It's going in the opposite direction. Wait.
Well, that's what I said, but just based on these numbers, what?
Because one of them's negative.
Which one?
The bigger
The bigger one, right? The bigger answer right here, negative 38, is the bigger number. And
Well,
so
yes.
we're going to get a negative answer when we subtract from that, right? We're not going to get
Some people.
what?
Wait a minute.
You should get the same size. It would just be positive.
Oh, so whatever one's the bigger one, we'll just. If you
You'll
make the
take
bigger
the
one
size,
negative,
right,
it'll take the.
right.
So that we didn't, like, on a test,
That's
if,
enough.
what if you did, like, if you did the 22 as a negative,
That's what
and you
I'm-
got different ones,
It
is
should
that
be,
okay?
It should be the same magnitude.
So it's just the number that matters in this case, not the sign.
Sort of. Don't say that because in the next thing that we're going to talk about, the direction matters a lot.
Okay.
And what would matter here is that one of them had to be negative, right? Because if you had both of them positive, I'm guessing that's what some of you did, then you wouldn't get 20.4, positive or negative, right? So make sure at least one of them is negative to indicate a change in direction. So for number 3, I know you didn't ask about it, but would we have a different sign on 8 and 32 there? Where we're looking at the jet ski that's moving for a minute to velocity. Should one of those be negative?
No.
It's not.
Same direction.
Going in the same direction.
It shouldn't be negative.
Goes to 32, no change in direction because of the impulse, okay? So that's what I was saying last week, is you really have to pay attention to reading the question, not just finding the numbers. Because sometimes the way the question is written gives you information that you need to include. And then for number 2, to figure out the force, we're going to take this quantity here that we just figured out, plug it in for that, and then use that to solve for use the time of the collision to solve for the force. So we had 0.005 seconds for this change in momentum to occur. And so if we divide both sides by that time, we get force equal to negative 40,800 newtons. That's a lot of force.
What do you do?
Good job, baseball, softball player. Alright, number 8 is...
God.
Okay, a 0.2 kilogram kickball
This would be
approaches
a
a
good
person at home plate with a
I'll post it on
velocity
YouTube.
of 10 meters per second to the east. The person kicks the ball and causes it to move in the opposite direction, horizontally, not a projectile, with a velocity of 12 meters per second. What impulse was applied to the ball by the person kicking it? Okay, so force times time equals the change in momentum, also described as impulse equals a change in momentum, or causes a change in momentum to happen. So in this question, what variables do we know? Number 8. Mass. 0.2. What else? Okay, what's the initial velocity? 10 meters per second. And then what's the final velocity? Negative 12 meters per second. Here's and it asks us to solve for what is the impulse that caused that change in momentum to happen. So initially it looks a little confusing, because how do we solve for impulse directly? How do we solve for it directly? Like if I said force times time, but it is equivalent to the change in momentum that happens, right? So if we can solve for this, then it's equal to that.
I got him good.
So that's what we would do for question 8. So we would take 0.2 times negative 12 minus 0.2 times 10. Which gave us a change in momentum of negative 4.4 kilograms per meter per second. So when I said to some of you that it's probably an easy fix to fix the questions that you got wrong, the easy fix is the direction piece and that negative number in the question, right? I think if you weren't including that before, hopefully now you're kind of seeing it. Alright, last question is number 9, and that one definitely was a little bit different. It had some extensions to it regarding using this information a little bit differently to figure out distance. But I said I gave you the equation from first premise, so I'm going to B over T equals BF plus BI over 2, because there's no way we can solve for distance.
19 out of a million.
So question number 9 says, a 2,500 kilogram car is traveling to the north and slowed down uniformly from a velocity of 20 meters per second by a 6,250 Newton braking force acting opposite the car's motion. Use the impulse momentum theorem to answer the following. First, what is the car's velocity after 2.5 seconds? So let's just stop there and figure that out. So what information is told to us in that question number 9? Mass, which was 2,500 kilograms. What else? Which was
That's a police officer
20
behind
meters per
me.
second.
And then the force of 6,000.
Okay, 6,250 newtons is the magnitude. What would be true about this force? Why? Yeah. Yeah, it says it's slowing it down, a force acting opposite the car's motion. The braking force of friction is acting opposite the forward force of the car moving down the road. So the force should be negative.
Not 0, yeah.
Not 0, because we're solving for that, right? It doesn't say it stopped, it says how far does it, or what does it reach for a velocity after 2.5 seconds. Okay, so let's use the impulse momentum theorem to figure this out. So we have negative 6,000. Alex, did you get all these right?
No.
I got 6 and 7.
Did you get 9 right?
What's the answer? I got 8 seconds right.
Okay, so you didn't get the parts that I'm going over right now.
No, I
You
guessed on
probably
those
won't
ones.
pay attention,
Because I said that 12.5 is about
The excuses.
right?
Yeah.
2.5.
You gotta come up with an excuse for everything.
Okay, please.
These days, right, Brady?
I dislike
Back when I was
kids.
in Yale, no one ever would do something like that.
Exactly. Oh, how things change, huh? Okay.
You were just like me, Miss Hanks.
So,
You were gone
it definitely was not.
on. You and I could have been brother and sister.
Yes, because brothers and sisters are exactly the same.
Alright, I'm the same as my sister.
No.
No.
Okay, so what would you
Does
do
my
first?
sister act like me?
That's just a gender thing.
No. His brother doesn't act like him either.
You
His
have a
brother's-
brother?
My brother's worse.
Yeah.
You guys have different,
Different annoyance
and
levels.
challenges.
Brady
what
has
do we
many
do
challenges.
first here? Maybe.
Maybe just solve.
Yeah.
And then
Here we go.
make it smaller.
You might want to solve.
What do we do with this
That one is, thank you, so
Yeah.
negative 15,625 equals 2,500 times BF minus 50,000.
See, I got this, but I still got the wrong answer. Because where'd you get the 2,500?
There you go.
That's the birthday. Oh, I just didn't do it at all.
What is
What do we
on?
do now? Okay,
Minus the 50,000.
minus the 50,000. Sorry.
Now you just made me look like a meth addict.
With it right now.
Can you add it together?
You guys are. So we add 50,000 to both sides. And what did you say over here?
Oh, you got it. You said the number.
34,375.
Thank you.
You're throwing stuff at me.
Oh my god. Yeah, right.
Okay, so that's going to give us
11
13.75 meters per second. So some people got an answer of like 26.
If you've made it this far,
is the other
I'll kiss you.
option.
How about 32?
Oh, okay. I don't know about that
I'll
one.
post
But
it.
let's think about what the question said about what was the car doing.
If this goes viral,
Slowing down, right? It's
You're not
slowing
saying
down. And so if we think about that, if you had initial velocity of 20 and a final velocity of 26, what's the car doing?
accelerating.
Right, speeding up. And so we need to kind of pay attention to that. So if you got an answer of 26, it should have been like, uh-oh, that's not right, because it said the car was slowing down, and it was, and it reached 13.75 meters per second after 2.5 seconds. Emma?
Can I go to the bathroom?
And so that's that. We're going to use that information, though, to figure out now the distance that it traveled in that time, right?
I got confused on that part because the formula just doesn't make sense.
This is the formula, the one that we've been working with all
The
along.
d over t equals vf plus vi over 2.
Yes.
Oh, I'm used to the h over t.
Okay, same thing, same thing. We learned it
That's what I
as
was
d over t
sorry,
first.
So
Yeah.
think about it.
I'll think about it.
VF plus VI over 2 is the average speed, right? So
Yeah.
the average speed is also equal to the distance over time. So
Oh, because d over t equals b.
No, yeah, d over t equals v, which
I
is
just said
average.
that. Yeah.
Yeah.
I just said that. Ow, in my
Okay,
ear.
so we're going to take that information that we solved for before, right? We know it's an interval of 2.5 seconds.
Oh, that's
The final velocity was 13.75. Brady, shut your mouth.
Oh, you should have said it.
Your, the initial velocity was 20.
What?
Okay, listen.
You are over the top today.
You guys, all three of you, this is what I talked about last week, right? Being respectful of other people's learning, and we're not doing that right now. It's hard for me to teach, which means it's hard for people to ask these questions to learn. So you need to be quiet. So we're going to add those velocities together, divide by 2, multiply both sides by 2.5,
Brady's so
and we
annoying.
should get distance of 40-something, 42.19 meters.
I can't stand Brady.
For some reason,
He's so
that would
annoying.
be over to minus
Thinks he's a CIA agent? No.
In this case, it would. In
Like,
a lot
he
of
says he
cases,
went
it
to
wouldn't,
Yale.
because sometimes we do 0.
That's not California.
But because we had 2 numbers, that would be for length. Okay, so for the last question, part of that question C, how long does it take for the car to come to a complete stop? We can go back and kind of use this as a shell, but what would we change here? What would have to change?
0? Or wait, no, no.
Yep. Is that what you say, VF is 0?
Yeah.
Yep, so VF is no longer unknown. We know that we're coming to a stop eventually. And what is our unknown now?
The time.
Time. So we get rid of 2.5 seconds, and now time is unknown. Okay? So this whole quantity would be 0 minus 50,000, starting from 20, of course, which was the initial speed it had as it started to slow down. So now divide both sides by a negative 6 down to 250. And we get t equal to 8 seconds. So notice also that the negatives do what here?
Cancel.
Cancel. And so that gives us a positive time. So if you had used a negative force here, you would have ended with a negative time. And we've talked about before that we can't have that happen because time is not a vector. It doesn't have a direction associated with it. And the negative is a direction.
So we time travel.
Right. Someday maybe. In which case things in physics will have to change. But for now,
Wait, time travel's impossible?
at this point we haven't done anything.
Well, yeah, like, no, I know we can't right now. But you're saying it's impossible, like it's never gonna happen?
Did I say that?
No, but you said it's impossible. If it's impossible, it's not gonna
At
happen.
this moment it is not possible.
Okay, well.
water.
No, I was going to.
No, you were not. You
I was.
that for the last 10 minutes.
Shake your water ball right now.
Yep,
there we go.
No,
No,
How do you supposed to say that? Well, Danny doesn't talk. He just sits there. So it's not really just
Danny's in my vlog.
Yeah, I told you he was recording without.
No, I'm saying he's gonna be in my vlog.
You know what my YouTube video is gonna be titled? Some idiot vlogging himself in science class.
That's not positive language, Colin.
Don't listen to him. Vlog.
You guys, what? Do you have any other classes or you're just extra?
I don't have energy in other classes.
Oh, lucky me. Huh?
Yeah, you're like my babysitter.
First 2 classes of the day. And I just hear what I discussed.
What he's like, this is Spanish.
Yes.
Oh,
you're He was
You're
like,
like my babysitter.
I mean, she's not wrong. Because I mean, we could have we got babysitter, right? I can light him on fire.
God!
It doesn't, Alex. There's no gas.
I'm gonna go jump in the water.
There's so much hatred in this room, I can feel it.
Just make them stand under the emergency shower.
I'll do that. I would do that. Yeah, what?
Because that doesn't drain anywhere.
Yeah, that's fine.
And so it just goes all over all my stuff.
We'll get some towels. It's okay.
Last day of oh, I'm not gonna be in your class on the last day of the year. I'll come. And I'll pull the shower.
I mean, I'll still be here, so.
I'll pull the shower.
Alright, so hopefully that helped for those questions. I'm guessing it was a sign,
It was just a negative.
a negative sign.
It was the formula for me.
This one. The
It
rest
was
of
the
you said you only got 6 and 7, right?
No, I just didn't have time to check all mine.
Mr. Anton, come with these.
You wanna just join our
Come
class?
learn the shape.
I don't know what she's talking about.
Yeah, this one. You don't know it, Mr. Anton?
No, I never heard of him.
Well, now you know.
I think he would fit in this class very well.
He would not fit any calmer, that's for sure.
My mom has an app on her phone that makes noise. So if she wants me to do something, she's just like,
It's what noise? Oh, with noise.
Jeez.
My husband has one that is a lightsaber, so.
Cancel her. Am I right, vlog?
And the light he takes out his phone and turns on the lightsaber noise and pretends to lightsaber.
wait, who?
My husband. Boys never grow up. Ladies.
I will grow up one day.
They don't. No, they don't. You will get 20 years old, but you will not grow up.
My mom, so she was cutting fruit and I was going to bed, so I said goodnight. And then she like literally was holding her knife and went, "You're not going to bed." And I was like, "Stab me." And I was like, "Oh."
Yeah, I don't threaten anyone with knives.
And then
Jeez.
my stepdad's over there like, she just threatened me with a knife. And I was like, "Yeah, I never know."
Damn, you
God, that's a, look at only the red ones stuck to the thing. That's nuts.
Discovery.
Red is more electromagnetic than yellow.
Is that going in your vlog? This whole thing's going in your vlog.
My 20-minute vlog.
I don't know, that sounds a little deep for this vlog so far.
I'm sorry, but what if Alex just recorded his whole entire day from the second
I think that's what he's doing.
to the second?
We're only at 19 minutes.
That would be only 19. That would literally be like a long time. 16 hours of just straight.
My phone would die. My phone's probably gonna die. I'm at
Just go live on something.
23%. I don't have service to go live.
Got back on the stream and started playing again.
That is.
The video was like 14 hours long.
You watched the whole time.
No, but we did. Remember? We skipped through it.
Remember when oh yeah. We like fall asleep on FaceTime and like nobody came. I took that video. I think I actually like that was that really nice.
Don't know what they're talking about.
When you need your computers.
Good thing I got mine out.
I'm all set. No more Gizmo.
Brady, do you want to be in the vlog?
I already am in the box.
That's Brady. He has a learning disability.
Every time we do Gizmo.
It's not something to laugh about. I have to cut that out now. God, I have to make a cut in the video because I started laughing after I said you had a learning. Cut! 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 Gotta cut that out. Don't forget. Yeah, so welcome back to the vlog. Sorry about the cut there. Brady was just being an idiot and said the N-word, which cut again. Can't say that. He did not. Alright, welcome back.
Like 30 minutes.
Back on the air track.
Running through the house like that. And I was like, did I make
Sorry about the change of POV. POV. You're watching me.
Did we break it?
No.
How do I do this? Gizmos.com?
Okay, hold on. No, you go to Clever.
Cleaver.
You don't really need to get logged in yet, but you can multitask
Wow.
and do that. But, well, let's talk about it. So here's the thing. So prior to this year,
Chromebook camera.
True. I'll just start a double vlog.
Brady, do you need a new seat?
No, I like this one.
Well, okay.
Over in that corner.
Yeah, exactly. We got lots of options. So let's just pay attention.
Now we have the double.
Prior to this year, this is a lab that I always did as a virtual lab because it's hard to recreate this experience in the classroom. And so what this is an air track. And I have some over in the corner, you can see them, they're silver, we have some red and gold little things on it. But basically what it is, an air track is like a air hockey table where you attach a hose to an air source and it blows air out of the holes. And so basically it creates a layer of air that the object on it can sit on and reduces a lot of the friction that would normally be there, right? You've played air hockey before, I assume. And you can feel the air coming out and see how when it lifts up the object, it's a lot easier for the puck and the little, what do you call it?
The stick.
I guess the stick, yeah, I don't know, the paddle. It's a lot easier
Not
to
ping
slide
pong.
that around too, okay? So an air track is basically a frictionless environment here, and that's what you're
Shout
going
out to all my
see
Canadian
in this
viewers.
little simulation. So I really do need you to listen to some of the details about how to use this air track, okay? Because it's not necessarily intuitive, because the whole goal here in the past and today, Alex stopped, or this week, is for you to explore elastic and inelastic collisions without me telling you what they are yet. Because I want you to try and create your own understanding about what is the difference between them. Today is our first introduction to basically the law of conservation of momentum. And to understand that, we have to be able to decipher between, are we looking at an elastic collision or an inelastic collision. And so to get things started, you're going to do this virtual simulation to kind of see what they look different and make some distinctions on your own. So let's look at some of the details that you need to know to be able to run this. Okay, so first thing is, in the past, I today had to change it to Gizmo. It's usually, in the past I had used a different air track, but it was Adobe Flash, and we know that after December, Flash is gone. So I quickly had to rework some of this for
Why did it
Gizmo.
go?
Yeah, what?
I have no idea.
Wait, did all of Adobe die?
No, Adobe's still a thing.
What is it? I don't even know.
Gone.
Wait, really?
DED.
It's the games that run on that. They don't
Yeah,
have it.
that software is.
I'd like to welcome back Colon McGreevy to the vlog and Officer Danny Cameron. I had to make a cut. Because I said
I had
Brady
to
had a...
change it from the colors, so the blocks and the other one were different. So anywhere if it ends up saying
Can I
orange
mute myself?
in the document there, then just
Focus.
know that it should say red because there's a red block here, but it was orange and blue block in the other simulator that I usually use. So just, you can.
Don't you have air tracks?
Well, I do, yeah. I was just saying that. I have air tracks, but you can't really get the data that you can from this.
You should do a demonstration. Show what it looks like.
Well, I don't want that up on.
I can get it out while you guys are working on it. So we're good. It's not quick.
Got a bowl cut going.
Danny and Colin, you need your computer.
Yeah.
My computer's good.
Charge it. Charge it.
Thank God. Look at me.
That's an
I
awfully
always come
hot
full prepared.
coffee pot.
I had to take money out for
They
stuff.
taught me that when I was a Navy SEAL in Pakistan.
Stop! You're gonna break it. Yeah, no, it's a Chromebook thing.
Okay, I need to get through this explanation so people can actually do the simulation and learn. So just pay attention. Okay, so general procedures for using this. Once you get in, so you need to log into Gizmos via Clever and find the air track that should be on your page.
Wait, I'm on Teaser.com.
Sorry,
Sorry, no, I was confused.
Yeah, you're so